He's another one of our streamers, but maybe he's stepped away from his. Okay. Okay. Thanks, Ryan. All right. Welcome. Bienvenue. It's another week. Hacknight NeuroTech SF. And just wanted to say thank you for shifting forward an hour. Maybe I should have checked with more East Coast people if that was actually useful. But I wanted to, partly because we've got a slight conflict this week in terms of our local Python user group, which is doing a meetup on a Python data analysis workspace project. And so I wanted to give us the chance to do that, as well as give us more time to get stuff done maybe this week, and be ready for next week with more to show on the challenge. But we'll talk about that too. Is there anybody new this week that would like to introduce themselves?
I guess that'd be me.
Okay.
My name is Slava. I work in neurotech field professionally. I started I started my career in a startup that we work with insomnia, developing an application with EEG neurofeedback to treat insomnia. Now I moved to another startup where I'm participating in development of prosthetic limb and using processing EMG signals and applying signal processing, machine learning, all of that.
Okay. Well, thanks for introducing yourself. That sounds really interesting. Jaden was going to join us today and actually show off a little controlling a robotic arm, but he's not going to be able to make it. We're going to save that for next week. Now Matthew, is it Matthew who joined us last week? Yeah, hiya.
Hi.
Hey, not you already introduced yourself last week. I wasn't going to put you back on the spot, but would you mind telling us a little bit more about what kind of use cases you're looking at this in your lab? Yeah.
To reintroduce myself,
Yeah.
I'm Matt. I'm part of the Silicon Valley Social Innovation Lab. So I'm coming a little bit more from I work with a lot of neurodiverse kids. I'm looking for a lot of solutions for communication. And in particular, my background is in cognitive science and a minor in computer science. So I have enough skills that I can follow your conversations, but perhaps I'm not as practiced as an engineer as many of you are. But that's what I'm joining, is to finding AI and wearable tech solutions to make the world more inclusive and accessible for my neurodiverse students. Though the dream is to find silent speech interfaces for my non-speaking students. So that's kind of where I'm coming from.
Gotcha. No, thanks. Yeah, that reminded me of at least one additional piece of clinical news for this week, which will, well, I guess it's we can jump into news unless there's anybody else who's new to NeuroTechX and would like to introduce themselves. I'm just gonna check the chat.
Hi, this is Chris. I'm not new because I participated last week, but I like to renew the spiel for the people that was not there.
Sure.
So I'm part of NeuroTechX Toronto, together with John, who is here. You see his picture down, and basically Yannick, of course, and Morgan, and basically we are part of Cognition. On a side here in Toronto. I am the only element here. And Connection is a company that assists disabled people that cannot communicate, they cannot speak. So maybe, Matt, if you want to be in touch later on, that would be my pleasure.
Oh, that's great, Chris. Yeah, I did not know that.
That is so cool. I would love that.
Yeah, cool. Sure.
Great. Okay, and I will try to turn down my other speakers. Terrific. Well, we're gonna try and don't really have any presentations for this week, but I did want to give us time to talk a little bit about updates on the challenge and see if we could, I know Andre will be trying to join us maybe in an hour or so. But if anybody did have anything to talk about in terms of the challenge, questions about the challenge, but what I would love to hear is what we can do to, as the kind of Neureka challenge workshop or working group, what we can do to help develop some of the scripts to get people started. I saw Joseph offered to host resampled data. Not that I thought that the sampling frequency was the biggest problem with that data set, but any updates on the challenge? Did everybody get to see the webinar? I thought that was, it was quite useful in terms of the, no, I don't know if others have been catching all the summer school and conference, online conference stuff. I also, yeah, I got the feeling that was also maybe taking a lot of time this week. Which, I've certainly been trying to do too, which starts rather early. So
if you have attended the GTech spring school, definitely it was early. It was already early for me. So for you guys, that was quite early.
I'm going back and forth because I've been catching. I think I told John I was catching the BrainBox Initiative webinars too, because those are. The ultrasound was really great.
That's great.
Yeah.
I also follow Morgan. Sorry.
Yeah,
I didn't want to steal you the speaking stick, but it's good that because you attended something complimentary to me. So I've been waking up at 5 o'clock, basically 2 days this week, to try and follow and catch up. Then probably I was online at 6 or 5:30, but I was distracted at the beginning when you started talking about GTech because I was responding to Matt on the chat.
Sure.
So we're exchanging emails, but basically I've been taking screenshots of every page of the presentation. So, and they're sharing a lot of materials. It's extremely interesting, especially the part of the multi-scanning, intracranial recordings from Peter Brunner and the sessions today about the sports devices. And, I think it's a really great workshop. And honestly, I learned a lot about that.
Yeah.
Are they posting the sessions? Are they going to be available offline?
Yeah. So I don't know if it depends on the fact that you logged into Zoom, but I think it's independent from that. So if you have an Eventbrite invitation and you are SVP, you probably already receiving it in an email.
Good.
Yeah.
There was also the NeuroModCon conference this week, the New York Neuromodulation virtual conference thing, which was pretty good. Lots of sessions, lots of parallel sessions. Like they had about 4, like TES, TMS, FUS, like all concurrent. For some reason, they decided to do it that way. But hopefully, that's all going to be posted online as well. So there's like a stack load of webinar material that's come out of that conference.
Yeah, John, I wanted to ask if there is a repo for this kind of material so that I can share it somewhere.
In terms of, I mean, all the slides.
Yeah.
Well, I mean, let's see what they. I mean, I would love to press the conference organizers to release everything in terms of all the video streams, and hopefully that includes, you know, presentations too. But if it comes to it, you know, yeah, that would be great.
I think it's not against their business model because they already make it public right now. The shortcut is I could ask if I can share mine.
Sure. Yeah. So neuromodulation, and you know, BrainBox is continuing on until next week. So for those who aren't familiar, but and yeah, Charlie Stagg will be doing, I think, the talk Monday. So Monday afternoon British Standard Time. So there's yeah, I knew that I was certainly caught up with a lot of stuff, but in the news, let's just switch over here for a second. There was some interesting news in terms of a new challenge. I don't know if you know, I don't know how many people here are neuroimagers, but this is Vince Calhoun's imaging center in Atlanta. And so this is just announced in terms of an Fmri challenge. And it does, you know, anyway, so, you know, I wish we covered more neuroimaging, but I want to be, well, I don't want to be biased. So I wanted to point this out though, because certainly I think it does point out what we need to be putting together to help others with the epilepsy challenge, you know. And so, you know, even though, I mean, this has been one of the big questions that people have asked in terms of, you know, why aren't we doing this on Kaggle? But just so people saw this, and I don't know. Oh, the other thing that I wanted to point out about this, John, was that I don't know if you see here, but this CoinStack toolkit, they're actually doing federated learning. So, you know, in terms of at least neuroimaging, I don't think this is actually using OpenMind federated learning, but it's using something maybe what King's College put together in terms of allowing you to, you know, keep your data private and local and yet share it for, you know, greater machine learning projects. Okay. So I thought that was interesting in terms of how they potentially did that, or at least, you know, it apparently it's not so computationally intensive that it's impossible. And I don't know if everybody saw the this was also and sorry. And this is imaging focused news, but new source AI framework for medical image processing. You know, this is a King's and So,
Are we supposed to see your screen? Is it just me that seems to be lagging a little bit?
His voice.
It's breaking up a bit for me as well.
sorry. Okay, it's me. It's internet connection. You're not seeing it.
Can anybody hear Morgan?
No, I think he.
Mm-hmm.
Oh, that's right.
Yeah, it seems to happen from time to time to Morgan's connection. So
I'm sorry, guys.
It's the Russians mining the bitcoins on his computer. Every 10 minutes, there's a block. Don't worry about it, you guys.
that's correct.
Are you seeing?
Nope, not back yet.
Okay. I'm just saying audio back. Can you hear me at all?
Yeah, I can hear you.
Okay. Okay. I'll start this back when my connection is.
It's hard to hear what you're saying, though.
Yeah,
okay.
you're still breaking up a little bit. So in the meantime, just quickly, I'm like, sound like a cool. But,
Yeah, Yannick, Yannick could be a backup host for times like this. For
yeah,
anybody.
just I'm curious to know who's currently playing with the TUH dataset as part of the NeuroTechX challenge, whether it's to participate or just for notebooks and trying to help and build something. But I'd be curious to know who's actually started to play with it. So if you guys either vocally or in the chat.
This is Simon. I've played with it just a little bit, but the only thing I've done that's even slightly useful is use the new pathlib to get at the files, which is very trivial in terms, I haven't done anything interesting with it yet.
Okay. And was that mainly because time or complexity? We're trying to understand if people are having difficulties at different stages, because the data set is a bit more complicated than most people have been working with in terms of data. The fact that there is different like sampling rates, different channels configuration, the file organizations, and there's many things that people might not be as used as normally, the size data sets, etc. So if there's anything we can try to facilitate in the notebooks and creating tutorials.
Yeah. Oh, sorry. Please go ahead.
Go ahead.
When we started looking at the data set, there's inevitably when you try taking a block of data and feeding it into a neural network, there are all these pre-processing steps that need to be kind of worked through. And the good and bad of having a large data set is, on the one hand, once you get everything up and running, the training is really nice and you get great performance and all that other stuff. On the other side, it usually means that there's a lot more upfront work. So the things that we kind of saw when we dug into the data and kind of realized that this is going to be a little bit, of an undertaking were things like all this stuff has been discussed on the channel. So I'm mostly just sharing my experiences rather than, trying to like come up with something wholly novel that we haven't discussed. But the biggest issues were things like, okay, there's almost 3 sets of data based on which types of collection was used. So the first question is like, okay, well, which kind of data is the most useful? Then the sample rates was just discussed recently, but yeah, like either the data has to be resampled as part of the pipeline, or potentially a resampled data set can be provided. But it just means that there's sort of a handful of things of like, well, the electrodes aren't the same, the placement of the electrodes, like most of these data preprocessing pipelines will go off of the columns that you want to feed in. And so when the data set is uniform, it's fairly straightforward to say, well, grab the first column, that's going to be the first electrode. Grab the third column, that's going to be the third electrode. But in this data set, the order of the electrodes varies. So it's not quite as simple as saying, you know, we'll just treat channel 1, 2, and 3 the same way. You actually have to have a little bit more logic to sort of pre-process it and understand, like, if I'm going to be comparing the same channel, I need to have like to like. So it's just mostly, as far as we got, was mostly that sort of thing, where it was basically like, okay, there are a lot of different permutations of how the channels present. And so either you need to use something like NEDC's PyStream tool, or you need to build in some logic on your pre-processing front end to deal with those variations. And then there's a little bit of work in terms of like which electrodes and which data set and so on. I think it's all absolutely doable, and this is standard stuff that people wrestle with. In a weird way, I think this is a very, very representative data set of what you encounter if you're going to try to do a few hundred subjects or, you know, lengthier recordings or whatever. So I didn't see anything in there that seemed like out of line or like, wow, no, there's no way that this could work or we need to fix it. It was just more like, wow, this is all the standard stuff that you spend weeks on when you wrestle with a data set, and then you finally get past it to the cool part, which is the analysis.
Hi guys, can you hear me now?
Yes. Yeah, I can hear you.
Yep.
Okay, good. Sorry about that. Are we getting into some details about how we can work on the challenge infrastructure?
Yeah. And so my suggestion was going to be that it might make sense to have like a 1 or 2 hour call once a week for people that are working on the data set, just to kind of compare notes with each other and talk about how they're working through these things and stumbling through it. I mean, maybe it's overkill, maybe it's not, but I think it would be useful to have like a place where people can just chat about, you know, what they're running into and how they're working through it.
Yeah, I would. Do you guys want to suggest it on the kind of like the main channel and on Slack in the Epilepsy, and just say would like to organize a call and see if people are interested with this idea?
Yeah, that's where I was going to go with that. So maybe we can do that as a follow-up item. I'll just double check with you, and then we'll set up a call at some time that makes sense and see if people show up.
Awesome.
Cool.
No, great. And so this would be covering, you know, like follow up on the kind of webinar stuff, or really getting into developing scripts?
I was just imagining that anyone that was actively working with the data set could just talk about, you know, how they're resolving these issues. Are they taking a subset of the data? Are they picking a few people that have kind of like a similar structure to their files and just kind of tackling that?
Okay.
Just kind of like the more mechanical aspects of it.
Okay. And what about our own working group in terms of, you know, expanding on Yannick's script, and you know, the other I'm afraid to I'm afraid to do this without jinxing myself, but so the other paper I was going to share was or, you know, research I was going to share, this is with Anders Eklund, who, if you don't know from, you know, this is Anders' first, it's his first EEG paper. he announced it as. And so I know him from a project called Broccoli, which he developed at Virginia Tech so it's like doing all first level fMRI analysis using OpenCL. So it's on a GPU, you know, it's like everything is just all fMRI operations are just instantaneous, and it's pretty remarkable. and it was used to support Virginia Tech's program of hyperscanning and real time fMRI neurofeedback. And anyway, so here's so that's his background. I think it's really interesting that he did this, and he's using the Temple University data. So I was definitely going to ask him about it, but this is it's definitely. I mean, this is obviously using more than just the seizure data set, but again, like, I think we should have a very long-term view of this particular data set, in that the seizure is still like only 10 or 15% of the data. And this kind of data normalization, or like standardization across all the different recording systems and sites that are included, it's a really an interesting approach to that, that I'm sure is useful for more than just interpolating a single channel or something. But anyway, just wanted to point that out as a recent popped up recently on bioRxiv, and I'd still love to see us do adding more to what Yannick's already done. So and then actually, is it up there? So did everybody see the NeuroMatch Academy coming up?
Yeah, it looks pretty good.
Yeah.
It's pretty intense. Pretty weak.
Well, they really did. I mean, we were talking about getting Zoom bombed, but NeuroMatch got massively Zoom bombed during their so Conrad Gording, who the professor who led NeuroMatch, actually has a Medium post on how to thwart Zoom bombing. I don't know if anybody saw that, but yeah. So I don't have much more in terms of we don't have any real updates. I think everybody was okay, somebody's in chat not able to hear us.
I remember that last time or a couple of weeks ago, someone was saying that they could not hear you but could hear other people. So I don't know if Mayank Jane, if you can hear me and not Morgan, or just you're not hearing anything. So I'll just assume if you're not answering me, that you're not.
Yeah, it could also be a browser issue. Like Chrome works a lot better than Firefox, and so some of those might be a little strange with device settings.
Okay, it's working now. For some reason, Chrome muted my tab by default.
Okay.
Cool. Welcome.
Yeah, hi. Would you like to introduce yourself?
Yeah, sure. So I'm Mayank. I'm currently a high school student. I'm 17 years old. I'm really interested in brain-computer interfaces. I've built a couple things using the Muse headband. So some things I've built are a brain-controlled snake game. I've used artificial intelligence, like deep learning, in combination with EEG devices to make algorithms that can measure focus. So one of my favorite apps I made with that is this app that measures your focus while you're listening to music, and then it'll measure your focus And then it'll start to curate playlists for you based on the data it collects. So you have this playlist of music that helps you focus while you're working. Right now, what I'm working on is creating my own EEG device because I'm trying to go delve more into sleep tech. So I want to create my own device that I can then run my deep learning algorithms on.
That's awesome. And what did you use to communicate with the Muse? Was that Muse LSL?
No, I just use Python. I used the sockets library.
Okay. So, I mean, maybe PyGat, or did you really get down and write your own socket stuff?
I wrote my own stuff. So it uses Muse Direct a bit. So it'll communicate over UDP, like the open sound channel stuff.
Ah, okay.
Yeah.
Interesting. I mean, I'm curious. And is that on GitHub?
I don't have it on GitHub, but I could make it on GitHub.
Okay. I mean, I'm interested personally just in ways to communicate with Muse that bypasses our Muse LSL stuff. I mean, I as well as I would like to fix the problems that we're having with it, but that's super interesting. And what are you doing to? I mean, how are you getting enough data to find deep learning useful?
I collected myself, so I'm not sure. It probably won't work on everyone. I collect data on myself, so once I start improving the algorithm, the idea would be to collect data from several different people, and that way the deep learning algorithm can do a better job of generalizing.
Sure. Gotcha. And you haven't. I mean, you know, there are some repositories of data online. You haven't played with any of those?
No, most of it's just been working on stuff myself, collecting my own data, creating my own algorithms.
That's awesome. And so, in terms of now, you're
sorry to interrupt. Like with sleep stuff, you're gonna want labeled data. So it's quite laborious to get labeled sleep data because you're gonna want it basically like manually or semi-manually labeled by sleep stage over like 12 whatever 8-hour recording. So that's the kind of thing that would be relatively hard to generate yourself, unlike a lot of kind of BCI stuff. It's a little bit more germane to kind of self experimentation, but you'll run into that issue with sleep, I'm afraid.
Yeah, makes sense. I'm building out the hardware right now. I'm going to be looking into that later, but I think, yeah, that makes sense because from what I know, I think it's that you have professionals who look at the EEG data and sort of label it as either deep sleep or like certain stage of sleep. So I definitely couldn't do that.
Yeah, but what you could do is you can get some kind of coarse-grained sleep staging from actigraphy devices, like like an Apple Watch if you have that, or a Fitbit type devices.
Yeah, that's built in.
So if you can kind of figure out how to do that concurrently, then you can get some labels from there.
Yeah, that would be cool too.
Yeah, great comment, John. Mayank, if I may ask a question, what hardware are you using of preference?
I've only used the Muse headband just because I won a couple of them from a hackathon, so that's just the hardware I have. I haven't used anything beyond that.
But what do you use for your own hardware?
Oh, I'm making it from scratch. So I'm using like operational amplifiers, instrumentation amplifiers, bare parts.
That's impressive.
Yeah, that's super impressive. Just to John's point about labeled data, the repository I would definitely recommend is PhysioNet. Physionet.org, which also happens to host a number of BCI data sets and another epilepsy seizure repository too. But it is definitely super useful to have some training data for that.
Okay, on the site.
There is actually also an M&E tutorial that pulls some sleep data from PhysioNet. I'm just going to link in the browser for you via useful reference.
Okay.
And M&E's
there's this one really interesting paper I read where they used a single electrode to accurately measure the sleep stages. I think they got like 90% accuracy or something. So I'm going to try to work off that paper.
Sure. Yeah.
Just a slight. Oh, sorry.
No, go ahead, Alex.
Oh yeah, and I mean, if you're already familiar with the Muse hardware and the Muse data aspect of it, just so you know that they did release this brand new device that's sort of tailored around sleep called the Muse S.
Yeah, I heard about that.
Yeah. So I don't think it's quite fully supported within their SDK and whatever, but as you experiment with this in the next few months, might be a useful way to, play around with it, or it might be overkill for what you're doing. But at the very least, it's something you could conceivably wear while you were sleeping, unlike the regular headband.
The funny thing is, my goal was to create something comfortable that people could use while sleeping, and then Muse S actually released a couple months, like I think about a month after I started building this.
Yes.
But my idea is that I feel like the Muse S is pretty expensive, and I think I could outdo them on software.
Yeah, no, that's cool. That's cool. I mean, I think it's great to start with a functional task that you're trying to do and kind of let that drive your exploration. So I think it's awesome.
For me, I feel like my worst case scenario is I just learn a whole bunch about VCI hardware, even if I don't make like a tangible company out of it.
Yeah.
How did you hear about NeuroTechX? I'm super excited actually to hear you talk about your journey as a high school student, already kind of like doing BCI stuff. So how did you hear about NeuroTechX and these hack nights?
So it started at a hackathon where I used a Muse headband, and I ended up winning Muse headbands. I thought the hardware was pretty cool, so I started building stuff with it. And then I started reaching out to people on LinkedIn in the industry to like learn from them. And one of them was Hubert. He's someone in the Toronto chapter of NeuroTechX, and he invited me out to these hack nights. And some of the people I reached out to were also from the UFC chapter, so they invited me to their hack nights as well.
That's awesome.
So Mayank, are you based in Toronto?
Yeah, I live in the city right outside Toronto.
Cool.
Are you going at UFT in the future?
I'm not sure. I still have my offers rolling in. I haven't heard back from UFT yet.
Got it. Because they have a student club, NeuroTech student club over there. But well, many universities now do have NeuroTech student clubs. So.
Yeah. I was part of that club for a while. Haven't had as much time recently. They had this presentation in Kitchener where I represented the club. I demoed some of my tech there.
Awesome.
At the museum.
Yeah, at the museum, the Open Brain Institute showcase.
Great, yeah. I couldn't make that, but I saw it was really good.
Yeah, it was a lot of fun.
Awesome.
Okay.
Cool. Maybe we'll see you around in Toronto then, Mike.
Yeah.
Yeah, I would just also point out VisBrain has a good polysomnography. Isn't that the right term? Polysomnography application that I think actually came from University of Montreal. But I love the fact that you're rolling all your own software too.
Thanks.
Yeah. Okay. Well, it's 7:00, and I
think there is another introduction.
Oh, please. Yeah.
We have Jag here. Jag, do you want to introduce yourself?
Yeah, absolutely. Sorry, I joined a little bit late, but yeah, I'm based in Davis, California, and I've been. I would like to thank Dr. McKelly for inviting me to this talk tonight, and yeah, I've been in brain-computer interfaces since my sophomore year. I did an essay for a class where I kind of started. That's where I kind of started figuring out what these are. And yeah, over the last 2 or so years, I ordered some of my own hardware from OpenBCI and have done a number of projects, and it's been super interesting. And I think my favorite project so far has been this sub-vocalization device that I was able to make using OpenBCI, and I tried to replicate some of the work that one of the MIT media teams had done, and they used like sub-vocalization signals from your laryngeal nerves. So it's
Alter
like
ego.
when you're. I'm sorry.
Alter ego.
Alter ego, yes, alter ego. That's the one. Yes. And yeah, so I basically made like a really like kind of a janky rudimentary version of that, and it worked out. It worked out quite nicely, and I made a post on it on Medium to kind of show how you can replicate what I did using OpenBCI, and there were a lot of people who really seemed to enjoy that, and like some of the other local NeuroTech chapters. I know the NeuroTech Berkeley chapter. Some of the students there are following that article to replicate it themselves as well. So yeah, it's been a super cool project, and really cool to meet all of these people here and kind of connect with other people in the community.
No, that's great. Thanks, Jack. And you said you're at Davis. You're part of the student club there?
Yeah, I actually started the student club here last year. So yeah, so it's been awesome. Just trying to connect with everyone who's also interested in neurotech.
Great. No. Terrific. I know Kashal's been on, and
oh yeah, you know Kashal. That's awesome.
Yeah. So yeah, I was just checking that you were a part of it. That's awesome.
Somebody is sharing on the chat if you can share a link to the project, Jack.
I'm sorry?
Yeah, if you can share a link to the project.
Oh, yeah.
That would definitely be cool. I had to look up alter ego. That's pretty good. But so I don't want to stop conversation in the sense of, if people do have things that they want to show, if they've got questions like that aren't on the agenda, and it's just, if we can help you with problems that you're having with your own projects. Thanks, Jack. This would be a fine time for it. There is the Bay Piggies meetup right now, which I sent a link in our meetup link. Just if anybody was interested in catching that, it is focused on Python data analysis workspaces, and I'm interested to see they are just, I think, entering the main talk now. But yeah, if you've got things that we could be helping you with, Hacknight's definitely the place to ask questions and get help too. So I don't want to.
So John, did you work on the EG notebook? I missed last week, so I don't know what's been the latest update. I know that in the schedule of the meeting, I don't know if Morgan put you on the spot to give an update, or if you agreed to that.
Sure. I gave an update last week. So the main thing is, well, there are a few actually, but one is that I'm doing a refactor to make it make sense more. So if you look on the branch, I'll put in the link. There's a branch called the Big Refactor, because there was already a branch called Refactor from 2 years ago. So,
but that was a small one.
Actually, I think it was probably bigger than the one that I'm doing right now, but whatever. Now, if you're familiar with the repo, then if you have a look on the branch, then you'll kind of and especially if you're familiar with M&E, you'll see what I'm trying to do. I'm just trying to make it look like M&E basically, the standard Python library layout, and just put things like the experiment, experiments code in logical places, as opposed to like buried inside randomly named folders, which is to some extent how it's organized at the moment. But if you have a browse on that branch, you'll see what the kind of plan is. And I would like to switch over to this sometime in the near future. And it's mostly, I have some more pushes to do. And, it's kind of obviously something I'm doing on the side, but this is probably going to be finished, this kind of refactor, fairly soon, in the sense of everything working, at least on my machine. The Mac stuff I can't test as easily. And there's a whole lot of other like organizing type things to do with updating the documentation. Another thing is data, which we discussed a little bit, but having some data fetches along the nylon kind of style, as opposed to keeping the data in the repo, which is not, is not kind of good practice really, especially if we want to kind of have larger data sets. So a lot of things along those lines. I also, I'm just starting to organize the issues and the kind of dev stuff on the project board. So if you go to the projects tab, you'll see I've got some lists and some cards in there. So between that and the issues, just trying to kind of organize the activities a bit more. But another thing that was kind of discussed actually in a call that I did with Morgan and Chris the other day is that we would quite like to kind of put out a call for developers and contributors and try and start to build up a kind of community around this, because there's probably the people around who would, who could comprise that community from the, 4 million people on NeuroTech Slack or whatever, however many it is. So yeah, like that's a message that we'd like to get out a little bit, is to kind of, invite community kind of contributors, people to join in and kind of just get in touch in the first instance, but then, check out some of the issues and some of the project lines and kind of see where they fit in, if they have some things they can contribute. So if everyone wants to kind of spread that word, then that would be very good. And a related thing as well that came up in this chat with Morgan and Chris is that, like, this is, it would be nice to have this as like a NeuroTechX I'm looking for a word here.
Focus, or
demo focus, kind of focus. Yeah, exactly. Something that is the thing that came up with that we kind of thought is an interesting idea is that there's a lot of people doing a lot of stuff. A lot of it is innovative and new, but a lot of it is also kind of could be kind of channeled. There's a lot of creative energy that could be channeled towards having a few really good tools that are serving the community well and are really top class. And so along the same lines as like a call for developers is like a call to everyone, but also to the kind of leads to think about whether it would be good to kind of think about channeling and having some EG Notebooks could be one, right? Moab is another. There are a few, like a small number of tools that we kind of get behind and make really good, rather than Joe's Python code that sits in his laptop and then gets disintegrates into the sands of time. So having a little kind of funneling of activities is something that we thought we could raise. So it's good to kind of mention that to you, Yannick. I don't know what your thoughts are on that.
I mean, yeah.
Yeah, I mean, I love the idea, and I'd love to help with these things. It's always kind of like project management especially at the very beginning, when you want to drive that, because it's easy to kind of like have a call for actions and developers, and a lot of people will be like, yeah, I'm excited. When the actual work starts, then this is where you see people dropping off after, and especially if the project management, or it's not tight, or the objectives, the goals, the incentives, why would I contribute? What's the goal? And is that a tool that people will actually use? If all these things are aligned, we definitely have a lot of people in the community that, yes, will want to contribute. It requires kind of like project manager or project managers for specific projects. For example, EG Notebook, if you release a call for developer, I think it needs a bit of structure in how would they do. Is there onboardings? Are there meetings? How are they going to work? Are they just kind of like going on GitHub, exploring and doing something? But with a little bit of vision and project management, I think it can go a long way, especially with like things like notebooks, which are, I think it's a great tool. So building on that and identifying the missing pieces and what needs to be worked on. 100% aligned with that.
That's useful comments.
Yeah. We talked about some regarding those issues too. I mean, in terms of like looking at Moab and how Moab had set, in their issues had set tasks for like newcomers to the project, or set that kind of structure would be needed. And I think, somewhat related, but maybe, slightly more focused is, can we bring in, how can we manage Jaden's BrainFlow merge? Like that would be a good example of, that's not so all encompassing. But I think we'll take some work, and take some yeah.
Sorry, I didn't want to interrupt you or take the talking stick from you. And
take the stick.
I did, I guess. Sorry about that. I wanted just to comment on what Yannick said before you, not because what you said is not important, but at the highest level, I think, Yannick, you are right that projects should be coordinated, but the point that we were trying to understand the last time together with Morgan and John was if this should be coordinated at the single chapters level or globally, given the critical mass that is kind of forming right now, like the galaxy is forming right now, and so there is a lot of interaction and so on, some new energy, like you said. So what do you think about that?
Oh, definitely as a global level. I don't think that it should necessarily be just locally. I think it's definitely globally, and also looking into student clubs that might actually have already used the notebook as a learning educational tool that would probably love to contribute if they had like small piecemeal component that they could work on, knowing that they can contribute. And yeah, I think that you could find a lot of talent if it was a little bit structured, kind of like, here are the tasks, here are the skills we're looking for, and having kind of like either we meet, we don't meet, so just a little bit of structure so that people can know a bit more what they get themselves into, and if that's a project that they want to commit and work towards. And once that structure is in place at the global level, this is definitely something that also will use all the different channels to try to get talent and people interested in doing that.
Yeah, thanks. And sorry, Morgan, for taking a talking stick.
No. I mean, it's yeah. So I mean, it's a little like with the challenge infrastructure. I mean, maybe we need to set a little bit more out, and explicitly with some docs and some smaller pieces of what needs to be done, and channel that appropriately, because yeah.
yeah, there's a lot for maintaining open source projects. Being someone who's worked on contributing to a bunch of open source projects and being someone who's been like helping manage like open source projects, not as a direct contributor, but just as like a product manager role. There's all kinds of things to be said about how you go about like what your governance model is for that open source project. So for EEG notebooks, like you have to label maintainers and you have to have code owners for certain areas and you have to have like a vision for where you want the project to be. And you have to share that vision and hope others align with it. So maybe, you know, I don't know how you can incorporate that opinion of mine into EEG notebooks, but if you want help or if you want some understanding of how other open source projects work, I spent a lot of time in the Kubernetes space recently, which is one of the largest like open source project like groups of clusters. It's like a galaxy of open source projects in that sense, and they're all orchestrated by the cloud native Cloud Foundry or something like this. And they track user contributions for each repo and what companies contribute. It's a model of models that's really brilliant, and they've really condensed a lot of learning about how to manage open source projects. So if you're interested, like talk to me on the NeuroTechX chat about that.
Yeah, that's
EEG
great.
notebooks, I just wish like I had an easy way to get into just to make cool stuff with the TUH dataset instead of Muse. Because with Muse, every time I go to EG notebooks, it's like, okay, Muse LSL. I have to install this, and then I have to have Muse, and I have to have PyQt5. So it's not quite what I expect when I go to EG notebooks. It's fine. It's great. Like I love Muse, and I'll play with it. And that person today, Mayank, Jane, I'm butchering your name. I'm sorry. The 17-year-old hacker kid who's like taking over the world with his like Muse headset. But go explore EEG notebooks and share some of your stuff. I'm sure you can drop bombs in that world and really make an impact. You know, so I think it's a lot of cool stuff. I love Jupyter Hub and IPython notebooks. So I don't know how I can make it better, but I will find some way. John Griffiths.
Yeah, that's great. I could probably do some more homework. Well, I definitely could do some more homework on best practices in managing open source projects. Like what I have is references that I just have seen with M&E and with DiPi and with some good, you know, the neuroimaging ecosystem in particular. But that's, you know, I should probably look more broadly.
But that's John Nolte, that's what we talked about Sunday in terms of, you know, M&E is a great example of, you know, when a new release comes out, the contributions are listed. You all that information is being continually updated, and we can really set that in contrast with, you know, some of the other very, you know, well-known, well-used projects where their development model is you know, opaque, and you know, it really does make a difference. But so just in the short term, I mean, I think you know, Jaden's merge is a really great opportunity in some sense, in a sense of like, it gives us some focus. It probably should be done with some sense of refactor, just in the sense of like, what would we need to do to make the EG notebooks less Muse centric and more open to, you know, other hardware streams and potentially non-LSL streams. Hey, Kyle. So, you know, I just think it's also such a great chance to, you know, I mean, I would love to see as like the first kind of like 3 board sets to, you know, have, you know, Interaxon's Muse and OpenBCI's set of set of boards, and maybe like NeuroSky or something, and have it just be like we can almost open up to everything. Did anybody respond to the person who was looking to collect data from Emotive? Is there a good Emotive driver?
Does OpenBCI run on Bluetooth Low Energy, or how do you usually use OpenBCI?
Is there any?
Yeah, I have it on a Bluetooth right now, and it took a bit to get me get it working, get the driver working at first, but then they released this new a repository called the PyOpenBCI, and I used that, and it worked pretty smoothly. But yeah, before that I struggled for like 3 months just trying to get it to connect to my computer, and it didn't work. But yeah, PyOpenBCI.
The best way I've seen to connect, like the most seamless way I've seen to connect to the Muse so far, has been this. Someone created an education tool where you just connect the Bluetooth to a web app because you can use Bluetooth low energy with web apps. Sure. It would be interesting if you created some way to connect that web app and stream it to a Python thing, because it was super easy to connect. You just selected it off the list of like nearby Bluetooth devices, and it worked right away. So if other headsets as well, if they also run on similar like Bluetooth Low Energy technology, you could potentially create an app that just lets you stream data from any BCI hardware.
Was that EEG EDU?
I think so.
Okay.
That's a good third parties, right? To interact with them lower Arduino hub, right?
Sorry, what? I couldn't hear you.
So you use libraries, third-party libraries, to interact with the Arduino USB hub.
The Arduino?
Yeah, the dongle that is used to communicate with OpenBCI is a proprietary format. So you're not going to be able to read it directly from the main board. You have to use a custom connection between the board to the USB hub, which is run over Bluetooth, like you said. Mm-hmm. But you can read, actually OpenBCI makes an SDK available that works through serial port. So literally it's a write and read serial connection with a USB UART connection. So you will be able to, for example, open MATLAB and use the serial library and write characters, and then activate a whole series of behavior inside the board.
Okay.
And there's also LSL module as well in Python. Don't know if anyone has tried
notebooks, like to create some one universal app for all the headsets, but I guess they don't all use Bluetooth Low Energy, so I guess you could do that.
Yeah, I just mentioned it, Maya, because you seem to be building, your own tools bottom up, so you might be interested in looking at the lowest level.
Mm-hmm.
So what did you think about the EEG EDU, the honest feedback?
I'm glad it's the only web app I've seen using Bluetooth Low Energy for BCIs. Like, I'm glad someone created it.
Yeah.
Well, that someone is
Kyle.
Yeah, Kyle.
That someone is right there.
Yes, I talked to him on the Slack.
Yeah.
We talked already. You're in Toronto, right?
Yep. Yeah, I've had a conversation with him.
Awesome.
So John, yeah, just quickly going back to the other John's point, I think that, and then looping in Morgan's point on the other EEG devices, I think, yeah, it's more about the vision and the roadmap, that where do we see the EEG notebooks and kind of like what are the next steps, so that we can start laying down kind of like, okay, the roadmap, here's the vision, here's what needs to be done, and then do we need like teams and code owner, as John mentioned, and subdividing that, or kind of like one PM can own, because these are all smaller parts. So I think that this is where instead of just doing small pieces that build something that we're not sure where the whole thing is really going, I think it goes back to the vision and road mapping a bit more. So I don't know if any sort of roadmap has been done recently, or
Not in as coherent a way as you're kind of describing there, and that does sound like a very good idea. There's definitely, obvious improvements, like Morgan was saying, kind of opening up the device support, and just as well, kind of bringing in more experiments. There's a whole world of cognitive neuroscience out there, and also getting more data, and kind of validating things a little bit more, or kind of having an idea of what the kind of measurements we make. Yeah, there are things that roadmaps can be built from, but that's a good point to just kind of step back and think about that.
Because if we can kind of okay, these are the experiments that we have now, these are experiments that we would like to have, here are the devices that are supported, here are the devices that would like to have supported, and kind of starting breaking it down, so that then we can have more call for actions and try to have people who would like to own some smaller pieces and work on different sub modules that will build the whole thing, but with a unified vision. That's how I would see it, but I'm definitely not as good as John with open source project and project management for software.
I just want to say quickly on this point, because Kyle, you just joined, and I think, Kyle, you missed this conversation from one of the last ones, is I'm doing a refactor of EEG notebooks to make more sense. So if you look there's a branch called the Big Refactor. So if you have time at some point, have a look. And then I'd be interested to know if you're kind of on board with that as a kind of change of how it's organized at some point. Hopefully it would make sense. It's kind of basically just putting stuff in more sensible locations and basing the organization off more standard Python library organization. So if you have time, have a look. That would be great.
Cool. Yeah, just seeing it now. And so it's different from the other branch, Refactor. This one's bigger and better.
Yes, that's, and it's that was important.
Okay, yeah, let me know if you want help with that. I see already this one link's broken for the Mac instructions.
Right, yeah. So again, the Mac stuff is the last thing that I get to, because I don't have a Mac, but I'm trying to make everything should basically move over, and it's just kind of the imports a bit differently. Yeah.
Okay. Cool, thanks.
Yeah.
Hi, I just wanted to quickly thank Kyle, I believe, and John, right, for the EEG notebooks tool and the EEG EDU tool. I just checked them out right now, and they look absolutely awesome. And I think we'll be using both of them. Me and Kushal and the NeuroTech group here, we're starting this online course with the whole coronavirus thing. It kind of gave us an opportunity. It's supposed to be an in-person course, but we started doing it online. So we've been recording some modules on introductory neuroscience and introductory EEG processing and basic machine learning that you're going to need to do some sort of EEG processing on your own. So we'll definitely be incorporating these tools into those lectures and maybe making some videos on each of them as well.
Okay, this is something fun. Firstly, thanks for the comments, and secondly, this is also something that we discussed recently. Oh, it's kind of a perennial kind of subject matter, but the kind of educational material mission or whatever. This is something that we could do with group touching base on both in a kind of general sense, in terms of there's NeuroTech EDU. There are some other NeuroTechX kind of resources floating around. They're kind of educational, but the content could be kind of more integrated and improved. But then specifically, basically this thing of producing educational materials is something that there will be some coordination on. So just keep your eyes peeled for those discussions, and we'll try and bring you in. But if you're making progress on stuff already, then tell us what you're doing. Let us know what you're doing, and maybe we'll jump in, or maybe we'll help out. Maybe we'll use your stuff. Maybe lots of things could happen.
Absolutely, absolutely. I'll be sharing the lecture videos with you, and still processing them. Actually, we still have to upload them tonight. They're still on a shared drive right now, the first couple. So we'll be putting those up on YouTube, and then I'll be sure to share those with you.
Awesome. Great.
Yeah, that's terrific. So, okay.
Hey,
yeah.
Jag, we're working on a blog post about EEG EDU right now, and if you could send me just a message to connect, just to get a quick like 1-sentence feedback that we might include, that'd be great.
Awesome. Absolutely. Sounds good.
Thanks.
Yeah, and thinking of getting feedback and people who deserve some credit. Just wanted to say Andre Parfenov would love to see the BrainFlow, his BrainFlow work incorporated into the EEG notebooks. And part of that is that he would really like to be able to say that that this has been adopted by another group, and will get as much use as the EEG notebooks do. So, I mean, I'd love to see that happen. He's wanted to also mention Josh, that Andre would love to get in touch with you and basically add support for NIRS as well. Yeah.
John, we have John Chibok in Toronto that is the local genius in FNIRS.
Oh, who's that?
Oh yeah, I know him.
John Chibok, I'll share the LinkedIn.
Okay, please.
Oh.
Please.
Yeah, John T-Buck is the guy who makes the Blueberry X.
Gotcha. Okay. Sure. Okay. So, and yeah, Josh did a prototype for that. Yeah. Yeah. Well, and again, I'd really like to make a concerted effort to bring up NIRS each and every week. Thanks.
I got some updates about NIRS.
Cool.
Yeah, we've been just looking through the MNE support for NIRS, and it's awesome. And we're gonna move that whole MATLAB toolbox into MNE. So we're working on a data loader now, and it's really like lots of active work going on. So like in the last week, they've pushed a whole bunch of changes for visualization of FNIRS, and so it's nice to be part of an active project.
Yeah, and so will we see this at your PyOptical project? Or...
Yeah, right now they've asked us just to make the front end loader for our type of data file. And we're just about there, so we can make raw objects with our data files. And then I'm gonna see how I can help with implementing other functions for analysis of the data.
Okay. Because yeah, I don't know if you saw that. I saw a recent paper from Gerton's group on pulse dot.
Oh yeah, that's cool. I sent it to.
Oh, we lost your audio.
Would you consider sharing a chat link for the MNE NIRS?
Hey, yeah, sorry. MNE FNIRS. This is the tutorial that I've been working through.
Yeah.
And chat.
Thank you.
And yeah, it's great. It's because it takes care of the co-registration of the location of the sources onto the source space of the subject, which is a whole nother software that we were using. And so it's going to combine 3 MATLAB softwares into that one ecosystem.
Perfect. That's awesome. And yeah, I saw a lot of other good stuff in there that I think will be useful once you get to the kind of spatial localization and the tomography. That's awesome. And I don't think our other Michael, maybe Michael's not here from. Toronto. But what we've been talking about in our own FNIRS, and because I know that this is what Ben and Michael are working on is even just a low channel count NIRS EEG, and then what you can do in terms of predicting one signal from the other, which is something that for instance Saul Diamond's lab's been focused on. Got some great papers on. I can post those. But yeah, for those in the Slack, there's an open NIRS channel. And this pulse dot was particularly interesting in terms of getting at some measures relating to vasculature that especially in older adults. So I forget the woman from the student club from the student club at Queens.
Abigail.
Yeah. So I don't know, I don't want to put any students on the spot at this time in terms of keeping up with everything, and plus doing their distance. And is she doing her thesis as well? I forget, but I think she might be finishing up. Yeah. Anyway.
Kyle, on something for you to do with your FNIRS, can look into can you reproduce bold Fmri anti-correlations and negative correlations? All right, because this is like,
you mean of like the default network, or
yeah, both the kind of the classic like task on, task off, but just in general, right? We just don't know how many of those negative correlations in bold Fmri are coming from like convoluted signal processing pipelines with global signal regression and all of that.
Right.
It'd be great to have like independent checking of some of those, particular features of bold correlation structure from a different data source.
So how many minutes of resting state do you need normally?
Well, they used to say 5, but now they say 10. But I think to see some, good question. I have to say, good question.
But some number that's greater
some,
than that.
Yeah. 5 or 10.
Okay, then well, I'll try to find a data set of resting state to work on that. Yeah.
Yeah, I mean, see if you can find like some like cingulate cortex like sources, maybe medial, frontal, those type of areas, and seeing some anti-correlations with parietal lobe, things like that.
Yeah, that's awesome. Okay, cool.
So interesting. I mean, there are a bunch of issues in Fmri that could be addressed or at least kind of explored with FNIRS that are like, how much is the signal processing and the artifact kind of issues that are boutique to Fmri, that we potentially have like driven large amounts of thinking in the field. We could do with some checks on those from other data sources. I'm sure people are doing this, but just
it has overlapping issues of having to model the hemodynamic response function and fit it to regressors. But you're right that there's not the other issues.
Yeah, I mean, I would have thought that it would be best done with a task. I mean, you could have the right.
Oh yeah, okay.
I mean, there's definitely some visual task stuff, some visual psychophysics that you could do that should generate, or with Fmri will generate these difficult issues, and much written about issues that would be lovely to look at with NIRS. I mean, a combined NIRS EEG, and I think I posted this in the Open NIRS channel too, but NeuroTechX is still doing webinars, and and they've got so one, the tutorial example that Kyle posted is what's written currently is a NeuroTechX reader. So you can do an M&E read NeuroTechX, and that is the data that is available from Berlin. So the MOAB data set the one MOAB data set that's multimodal is an EEG NIRS data set of motor imagery. And so it's unfortunate for a couple of issues. One is that it's the one data set that doesn't load in MOAB. So there's actually an open GitHub issue on this because it requires it requires a form. So you don't have direct access to the data. You got to go through a web form to then get access. And so anyway, the MOAB fetcher fails, even though it's only trying to get the EEG. But we could actually pull in the EEG and the NIRS data from that data set, and it's a GPL license, but they've just got they've got a web form. So the GitHub ticket is like, either we've got to write a special function to handle that, or we need to ignore that data set, or maybe I think because it's so perfect in terms of being a motor imagery data set, it would be, I bet we haven't actually asked the authors, the license, about that license. So maybe we could host it and have it available for MOAB too. But it can be read in with the current MNE. And you could be looking at some really interesting EEG NIRS already with MNE. And that's not the example data set that MNE has. So the example they have is from Marquette. So anyway, I would love to find more NearX people and talk to NearX about other data sets, because MNE's now a really looks like a really really useful NIRS tool at this point. And next week for the Paris meetup, we're going to try and get Rob Cooper from Gower Labs to come on the Paris Hacknight. And that's where he's got the Gower Labs develops the Lumo. I think I put that picture right last time, Kyle. If so.
Cool.
Yeah. And anyway, they I do like their form factor.
Yeah, I love hexagons.
And but I think it's a great question in terms of like there's a lot of MATLAB tools that are pretty much labware that UCL also, right? I mean, Homer came out of UCL, is that right?
Yeah, I think so.
I forget if that, or was that Boaz?
I think that's from Boaz Group.
Yeah, it was Boaz. Okay. Anyway, I mean, I think it's going to be great to see that in M&E, and yeah. So anyway, Rob, I know is at home with his Lumo, so I'm hoping he will be interested in doing, putting it to use, since he can't put it on subjects other than himself. Anyway, so that'll be Monday. And then in 2 weeks, we're going to have Gumpy developers speaking about BCI frameworks. And that's again, this is for the Paris, there in Munich. So just for those who can catch the Paris meetup, trying to have some presentations lined up, and they are still super interested to contribute to a Neureka Challenge, infrastructure project, and like.
Is the Paris meetup going to be on Jitsi like this?
Yeah. So starting Monday, Paris is going to be on Jitsi, and I've got to say the Skype's not been bad, in that it you can get in without having a user count, but yeah.
Is the meetup in French?
So they will. So I for the gentleman who joined because I told him about it, and and then was late because I was interviewing the Gumpy developer. They will be in French unless you say hi. Just introduce yourself in English, and then they will very happily switch over. And in a previous life, I could speak French, and it is not enough to talk to them for a few minutes. I quickly am out of my depth, so they very kindly speak in English.
Yeah, I'm supposed to know French because I'm Canadian, but I'm still pretty bad at it.
Okay, I need like a couple weeks back in France to around French-speaking people to get back in it.
Or Montreal,
yeah. I'll take Montreal. That's why I love to visit. Although in Montreal, it's not clear what language you should, like. If I meet someone, I'm never sure if I should learn French. In Paris, it's
where you are.
Yeah, I know. I didn't realize. Yeah. That was interesting to learn too. Anyway, we will be doing that on Jitsi, and I'm hoping that we can record it too. And so for those who can't catch these, that at least they're available offline. So definitely trying to get more presentations from Europe, and get them on the Paris meetup. So I've got the presentation. I've got the Bay Area Python group presentation going on. Is anybody actually watching that and catching this data analysis workspaces project?
You mean like you're in 2 meetings at once right now?
Well, so because I'm sure that you signed up with Meetup, and so you caught the agenda.
Yeah.
There was a conflicting, so the Bay Area Python group only has a meeting once a month, and
it's recorded, Morgan.
It's recorded,
and it's very slow. I've been watching on the side.
Okay.
It's really hard. There's a lot of like cognitive dissonance trying to like maintain the focus on the NeuroTechX screen webcast. But in the background, I have it, and it's very slow. And don't worry, it's being recorded. So.
Okay. Well, that makes me feel better because I'm gonna leave. It seemed, I mean, I don't catch all of their meetups, but when it's like particularly, sorry, Simon is, oh no, that's very late. When it's particularly like PyData related, then I think it's something that we could maybe benefit from. Okay. Who's sharing? Oh, you're catching both?
I'm sharing. I can turn it off whenever you guys want. I just wanted to show you what I see.
No. I mean, I am somewhat skeptical of these like, I'm going to manage your data science project with my project tool.
I mean, in theory, you could organize a NeuroTech meetup to just watch another meetup. Like we all get. That would be fine with me. I mean, I don't think like that's good content also.
Well, the one danger was that this wasn't a speaker I knew, and I wasn't quite sure what this project was trying to solve. I would still prefer us to get a data lad tutorial, or now I am it is hard to multitask.
Well, what is the scope of the Python meeting?
It's a project focused on managing data science projects, or managing your data science workspace. Sorry, I left that meeting, but in our meetup, I put a link to their meetup.
Gotcha.
And it's probably a good time to mention. So why is multitasking so hard? Well, Adam Ghazali's lab would look at that in quite a number of contexts. And I don't know if you saw that Achille had some news this week in terms of getting FDA approval for their online, or their web-based tool for ADHD. So that was a big announcement from Adam. I didn't actually follow the details of that FDA clearance. Let's see if I can find. Do you have that, Micah?
Do I have what?
Here it is. So this is their. Oh dear. Okay. Well, it's for those that don't know, I think Adam's a scientific consultant on Achille Interactive, and they've been taking some of the kind of iPad games that GazLab and now Neuroscape developed, and using it for therapeutic reasons.
He was able to release it for ADHD. He was able to release this product for kids who have ADHD without FDA approval because of the limited context in which he released it. So.
Yeah, that's what I was trying to get some more. Okay, so this is under some sort of COVID discretion guidance. Yeah. Interesting.
So if kids have been diagnosed with ADHD, then they can choose to use his game as a treatment, his EEG game.
And is it? I don't think it's an EEG game, is it? I mean, I thought it was I thought it's just a brain training, or
Oh, okay, my bad. I thought it was.
No, there is no EEG. It's really just the game itself, the cognitive training aspect of the game.
Yeah.
The long-term vision, obviously, is to include the closed-loop system and the whole thing with EEG, and then eventually brain stim and things like that. So this is the long-term vision for Ghazali and then Akili. But when you try to get approval for these things, the little thing that you changes everything. So, and then you need to kind of like do other trials and things like that. So you want to focus on one thing. If you want to go through FDA and you cannot change it kind of like over time, we're going to add this and we're going to add that.
Yeah.
So, but yeah, the current version of what you're looking doesn't have the EEG thing.
Yeah. Because it's kind of based on, going back as far as NeuroRacer. But a lot of this stuff was also used in older adults. But that is certainly, and so I guess this is because kids can't go to see clinicians, that they're getting extra approval for this kind of at-home use product. Huh. Okay. Well,
just to chime in,
yeah,
I find this topic very, very interesting, and it's fascinating to me to see the approaches that people do. So I was recently looking at the Brain HQ product and went looking on YouTube a little bit just to kind of see examples of like when people actually train with this, what are they doing? I find these to be really fascinating to just sort of look at. And from what I can tell, most of these seem designed around this approach of sort of like, if we come up with the right visual stimuli, something about how the user needs to engage with the content will hopefully help them, learn how to manage something better, the attention, the focus, whatever. Certainly, I understand all the research that it's based off of, but I really do find it fascinating that in general, the approach seems to be, and I get the limitations why. I get like, if you have hardware and you have an EEG and you need to like get all that stuff, it adds all this complexity and all this regulatory challenge too and whatever. But yeah, most of these things seem to be like an app or a program that you run, and then somehow by engaging with it visually and cognitively, you get these benefits. So I found that a really cool example that or I saw the same thing, so I was interested to hear. But yeah, I find it to be interesting. Anything that can help people show any kind of improvement, I'm certainly a fan of. I just find the approach curious.
Oh, sorry. So this weekend, I had the terrestrial TV on, and my wife came in and she said, "Is that an ad?" And I was actually on PBS, and it was a very long infomercial for Brain HQ.
That's awesome.
Yeah, and I was like, but look, I could see people I know here, So Mike Mersnick was on, and I think they also had a link into some other. I mean, they had people from other brain imaging centers talking about what this would do, and especially its utility in older adults. And it is, I mean, Suhas was on and talking about, the EEG and behavioral changes that come for those that follow this program, right?
Right.
And I think that's why, Kyle and others mentioned, so we're going to hear lots of howling for the healthcare workers right now. I could, if you're wondering, that's
Open the door, like the whole city or just your house?
It's well, we live just outside, just down the street from UCSF.
Cool.
So yeah, it's out in the street. My son is laughing that this is going on while I'm trying to talk. But it's like, well, if you are engaging in this kind of routine, you've really got the real comparison is putting this up against some sort of active control. The
Right.
fact that like through some sort of training program you have both behavioral and brain changes isn't isn't so significant. Certainly since since Jan Schultz showed, it's like if you juggle, we can find parts of your brain that have grown, right? I mean, in terms of practice juggling every day for 2 months, and we can find those, we can see those changes in the MRI. Yeah, the claims need a little extra.
I'm a bit concerned because wasn't Lumosity marketed on some of the same principles? I'm just looking at BrainCo right now. I've never, sorry, not BrainCo, the other one you mentioned. And I feel like Lumosity was marketed kind of similarly, and they turned out to be a bit of a not exactly what they claimed. So yeah, like a little bit concerned on that part, and yeah, there needs to be some more double blind control trials to like really make sure that they are accurately representing what's going on.
Yeah, and and again, like this came out in terms of I mean, that I remember when Lumosity got that largest ever FTC fine, right? And and certainly Adam's lab was very involved in these kinds of brain training, but he was on that joint letter with I think probably like about another 80 researchers saying like it's too early to say what's going on here. And I mean, I love neuromodulation NYC, and which has been going on this week, and I know John's caught some talks, but I don't know if you'd seen the guy who runs registered reports,
James Coolville.
I'll take your word for it. But recently on Twitter, he was commenting on the fact that there's still not been. I mean, I think with neuromodulation in general, you got a number of similar problems in terms of he pointed out that there's never been a registered report on TES, and that that does not speak well. We know it's doing something, but and certainly I learned from neuromodulation like how interestingly nonlinear some of the effects are, and some of the real effects are, but those are not what we model. Like our models don't predict these nonlinear effects, and yeah. Anyway,
so if you're interested, I know that I think 2 weeks ago or something like that, Shaida was on the call when we had the presentation for Plapitus. So when we had that talk, and I mentioned the book, but if you're into cognitive training, they wrote a pretty nice book. It's a bit intense because they are really citing. I think they're citing, I don't know how many papers they're citing. So it's not just kind of for people outside of the field. I'm not too sure actually who the audience really is, because they try to bring it down to a little bit the general public, but it's too heavy for it. So I'm not really sure who's the perfect audience. But if you are a little bit in the field and interested about brain training and also brain stimulation, brain enhancement, they cover also nootropics and things like that. How not to train the brain.
That's great. Thank you so much for passing that along.
Wait,
it's a good book, but yeah, you don't kind of like just go through the book as like another. It takes it took me kind of like a while to go through, and they cite kind of like a lot of papers, a lot of studies. They talk about all that from Lumosity to all the Adam Ghazali. They do list, I think, like 100 products or something like that at the end as well. So they're interesting.
What's do you have a link for that?
Yeah. Let me put a link from Amazon.
Thank you. I mean, I would definitely.
And if you're interested about that on Slack, you can hit. Let me just put her name. So Shaida on Slack. She's been doing her PhD in the field, postdoc in the field, writing the book, and she's been in that field for quite a while, interviewing pretty much everybody doing brain training.
You mentioned simulation, that they talked about that in the book, and I think that sounds really interesting because I'm taking a computational neuroscience class right now where they're looking at brain simulations and stuff, and so I think that would be a good approach to maybe confirming how changing neural networks or brain models in one with one way of introducing data or one set of training data, how that can alter the brain's response to another set of training data or another situation. And so just to see how two situations that aren't the same can still maybe, like, if you're training on one situation that is not the same as another situation, how it might still improve the brain and come up with quantifiable measures for that.
You mean like transfer learning, or?
Yeah, kind of like, yeah, exactly. Transfer learning, but more in the context of neuroscience, essentially.
Well, the juggling example is a good one, right? I mean, it's just, in that case, it's white matter plasticity. So the generalizable result of that intervention is a structural anatomical change that leads to improved neural communication in certain pathways, and that's your generalized effect.
Yeah, exactly along those lines. But and just being able to simulate that in a computational model, I think that would be really cool.
Yeah, and so an example is like,
that's my day job.
One of the focus techniques that BrainHQ uses, and again, this is just from one of their example videos, is they'll put like 8 or 10 objects on the screen. They use like bouncing balls or something like that, and you're supposed to track all of them if you can, or pay attention to all of them. So yeah, the part that I always find interesting is like, what's the relationship between, if your day job is a stock trader or an executive making decisions, and you go through these training programs where you're you're expanding your situational awareness or your multi-object tracking or your ability to handle different things even though you're stimulus limited. If you take that and you have someone stare at bouncing balls for 20 minutes a day for a few weeks or something like that, how exactly does that transfer into their day job? I think that's the really interesting part for me. So yeah, it's a really cool discussion, and glad to see people chiming in.
Yeah, like exactly. Like what percentage of the increase is in your ability to track multiple bouncing balls at the same time, and what percentage of it is in some neural circuits that are more like general purpose? Yeah.
Right. And I would always love it if these training things could sort of close the loop on that. Like, okay, let's say I'm a stock trader and I need to look at 10 different stocks because I'm doing like currency trading, real time, whatever, right? And so you can say that there's a real clear relationship between tracking a bunch of bouncing balls and like maybe looking at a bunch of stock tickers. But I would love to see somebody like get into the nuts and bolts of why that translates to that other skill. Just something I've always been curious about.
Sorry, that child is coming from my house. Yes.
but yeah, in the cognitive training field, the transfer is the holy grail and the main question. How does that transfer, and how does you training on one task? We all know that you're going to get better at that task, but how does that help you do other things in your life. So the best example about memory task and things like that, if you get better at basic memory tasks, but you go at the grocery store and you cannot remember what you needed to buy, then have you really improved your memory, or you just gotten better at the task? So, and you guys mentioned kind of like the bouncing balls, the multiple object tracking as well. So my lab has commercialized a NeuroTracker, which is one of the cognitive training tasks. So that's kind of like what I've been around for the past couple of years of like the brain training, the transfer. How does that translate and transfer to athletes, for example, or driving? So we train a lot of older adults trying to delay cognitive training and giving them the ability to drive longer with the multiple object tracking. So the ability to just kind of be able to track what's happening around you while focusing on a main goal. So yeah, the whole question, that's the thing right now where like the theoretical aspect of brain training makes sense. And with brain plasticity, like everything makes sense, but we just don't master and understand exactly, as you said, the kind of like the nuts and bolts of how can we make you better at stock trading. We just know that there's something there, that we can train your brain so that you will get better there. But how do we do that efficiently, and how do we validate and prove that and then scale across individuals? That's what is really, really hard.
Yeah.
But we know on paper that it just makes sense to continue in that direction.
Yeah, I wanted to add. There's a book that's on this topic that it's called Moonwalking with Einstein, and I don't know if anybody can see that, but
yep.
It's called Moonwalking with Einstein, and it basically they dive into how like, for example, the chicken scratchers is in Japan. There are people who are specifically trained on a certain task who it's not like it's a skill that takes years and years, and only like the top chicken scratchers are allowed to have that as their profession. And it's like there's all sorts of jobs like that where you have like people who can their job is to detect like the weather, and you can train somebody to predict the weather or to spot airplanes in the sky. And I think that my thought was that if you're just measuring someone's vitals or their brain activity or their eye tracking, that you may not be able to sort of reconstruct the libraries in their mind that they've had over time, that they've trained on all this real life experience and learning this specific skill in this specific area. But maybe you could use that to train. I think the holy grail here is if you can actually train a robot to, you capture all that eye movement and all the outward body activity, and if you could train a robot, then you could effectively replace that job with a robot, which is, I don't know, but useful.
There was a talk about this this week at the spring school of GTech. Let me pull out the author. It's Paul Seda from Columbia University. So he trained actually a reinforcement learning agent in the case of a flight simulator that had to keep into account the boundary, the automatic error of pilots during landing, and there is a psychological problem of having the boundary of the terrain, the ground, and then some other boundary that you don't want to cross above that. So, and that creates oscillations. So he tried to model the behavior of typical, landing strategies or trying to navigate in the sky in a VR environment. And that was very interesting because it was basically on the agent to try to coordinate that automatic behavior. I think that offloads a little bit of working memory.
Well, yeah, and so Matt is bringing up first-person shooter games and spatial awareness skills in military training, and I know that it's used, but I'm still very curious about the studies showing the efficacy, and getting around. I forget which week we talked about this, but I was talking about the Space Fortress game, Kyle, that came out of Graton's lab. I don't know if you remember much about those, but you know, I am curious about the upper limits that a person has in terms of their subcortical structure. You know, the volume. Do your MRI volumetrics kind of predict your band of performance? And there was actually a great. So I've still got this data set. Oh yeah. Was this you? Okay.
I know this one wasn't me. We've used Space Fortress, but we were late to the game. But
okay.
This was a crazy effect we found. You can predict the slope of people's learning just by their baseline alpha power before they play.
Oh, okay. Okay. Well, so when I was in Adam's lab, you know, we were doing all this brain training, right? And doing all these video games in the scanner, right? And so I came across this, one, because of the kind of effects that you're talking about, but two, because one of the first things that I found was that, like, you know, striatal subcortical volumes were predictive of reaction time, and you know, other kind of behavioral measures that we had from the game. And I was just like, oh wait, this is really an old effect. I mean,
yeah, that game's cool because it's like it was made by cognitive scientists, so there's little like cognitive subtasks, I guess.
Yeah. And you know, that was kind of NeuroRacer's thing, right? It's like, it's a driving game with cognitive neuroscience tasks built in, right?
Yeah.
And yeah. So did you have MRIs on those subjects?
Yeah, I just posted another one of their MRIs from that big project we were doing.
Because yeah, there was this IEEE brain / IARPA challenge, like 2017, that gave us a lot of. I mean, we had like MRI data and a bunch of. They'd gone through both brain training and stimulation, and we had MRI before and after. That, you know, was really trying to get at this. And you know, I was wondering how many people would actually look at the subcortical volumetrics in terms of you know, could you basically predict what, because that was actually part of the challenge, was can you separate learners into different categories, and then suggest different strategies, you know, and that would have won you higher marks.
Yeah, and the only thing I'll just finish saying is, in the military stuff is kind of interesting because I think there's been hodgepodge experiments, you know, in various use cases, but there's always been problems. Like if you use pilots, those are all commissioned officers, and there's a very small pool of them, and you're not going to suddenly boot them out because you did these metrics and you figure out like, oh, well, yours don't look very good. But from what I understand, a lot of the military sort of gaming recruiting stuff has been very focused on drone operators, because those are non-commissioned. Those are generally younger folks. They report, they're out of like one center, so whatever. But yeah, that one in particular seems to be a big area of focus, where it's like, how do we find the best people that'll do these sorts of tasks? And yeah, that really kind of goes into the predicting performance through stuff. I always found the stuff that you talk about there at the MRI, the GAZ lab, very fascinating, because it is cool that there are these clear indicators of sort of future performance, and it's fascinating to see how it plays out.
I mean, you know, IARPA wasn't just trying to, I mean, there was a real emphasis on, can you identify people that have a lot of growth potential? I mean, that exactly was obvious from what they were saying, was like, who are the people that we shouldn't, you know, that we should either we're doing it wrong, or or we need to give them more time or something, but that like that potential is there. And yeah, but I would be curious of how widely it's used. And there was this focus on that somehow playing this rapid reaction game was a brain training,
right?
At least it as the so this was also you know what, this was out of University of Illinois Urbana-Champaign. Yeah, I will find that. That's and I've still got that data.
That's awesome, Kyle. Thanks for sharing that paper. I'll definitely look into that.
I think that's $1 million business, but we should try to replicate that effect. That it was like a very strong predictor of how fast you could learn was just like your baseline alpha power and your task-based alpha power. I just made a promise to myself not to do any longitudinal studies before I got tenure. But I got it, so I can do it now.
Now it's game on. Okay, good. Yeah.
Baseline alpha power. That would be the first time you play the game. Is that what it was in this?
Yeah, and it's even like before they first play the game, they sat there and closed their eyes, and even in I think it's like the bottom right of that graph. So it was not only the first time they played their task-related alpha power, but even just their resting state was predictive as well.
Yeah, you'll have like one distribution of frequencies when you're at rest, and then from the experimentation we've done, whatever task you do is going to generate a very task-specific set of brain waves and signatures. But even from the experimenting we've seen, like some people have a lot less alpha power than others. Like some people have this really, really prominent alpha bump and other people don't. And anyway, it's really fascinating to hear that was. So generally when they do these recordings, you'll do like a baseline before the task of some period, and then you can compare that person's resting state to what was happening during the task.
Yeah, in this case, it was probably even just like the baseline period in between blocks or something. But yeah, that's better practice to do a dedicated baseline block. It's really interesting that your brain state. Yeah, so that makes me think it's a trait that people, or it could be a state, but if it's a trait that might separate certain people, that's an interesting way to measure it.
I'm always disappointed with the size of my alpha peak. just kind of.
John is not the size; it's how you use it.
I mean, yeah.
You just haven't found
out softballs here.
You haven't found the task that truly shows how magnificent your alpha peak really is.
So when I got to Illinois, everyone was doing ERP research, and they would throw out whole subjects of data that had big alpha because they interfere with the ERPs. Oh. So it's funny that that became the signal instead of the noise.
And have you brought this up to Bradley Wojtek?
That point about alpha?
Yeah.
Which one? The predictive power?
Well, both the predictive as well as the people with too large alpha.
Now that we're doing EEG analysis, you pull those people out. But I guess that they were doing kind of naive ERP averaging.
Yeah. Okay.
Where they couldn't even see the single trials.
Okay.
Yeah, if you're doing 1/F stuff, the alpha bump is kind of a problem because it pulls your
I see.
bottom line up. So it makes sense to me that the more prominent your alpha peak, the more it skews all your other metrics when you're trying to compare them. So I could easily see why that would be like annoying. Even when we plot the 1 over F, when we first started calculating the distribution, if someone's got a really big alpha, it just kind of drags that line up to be inaccurate. So you can notch it out and do other stuff to fix it.
But these can't be, we're, no subject's EEG is wrong. But anyway, his postdoc, I see her on Twitter, and she's been producing these like wonderful animations of EEG activity. Has anybody caught these?
Natalie.
Yeah.
Shawaroniko. Yeah, she's unreal.
Yeah, they're awesome, right? And so I think her most recent one was talking about left-right differences in alpha activity, right?
Yeah, I saw that.
Yeah. I mean, just I do think her animations are just incredible.
Someone needs to save them and put them all together on a blog because she's not doing that.
Yeah. Okay.
Can I tell you something funny? Is during the meetup tonight, the guy in the White House said that we could possibly cure the coronavirus with ultraviolet light, and chemical disinfectant that we can inject into the human body.
Yeah, right into the lungs.
Yeah, I mean, I forget if she's actually. I think she answered a question recently in terms of her process. I mean, just how she's generating these, but yeah, they are.
I think the best thing that she's doing is not doing work to focus on a paper. She's just like making nice graphics and animations based on data sets, and then that's the end.
I mean, it's not so much the end, but just it is refreshing to have someone talk, to highlight these particular problems or these particular issues, and and how often that gets lost in a paper's focus on getting some publishable results.
It's all stuff that you would like show your advisors at a meeting, and then they'd be like, "That's great, but can we move on and
right
paper together now?"
Yeah, this doesn't work with the flow.
Trying to publish an animation doesn't work well.
Yeah, there is that too. Yeah.
Adam Ghazali's done all right.
The best one I've seen is Parvizi's paper with the stimulation of the FFA, and the figure 1 is just a video of of it happening, and it's amazing.
Yeah.
El Monyemi TMS EEG one as well.
Yeah,
just a video.
Right. Well, what's the journal that will take videos? I mean, isn't there like the Journal of Visual Experiments or something? Like, what am I thinking of? It's not Jove. It's
Yeah, there's a Journal of Visual Experiments, but that's
spam.
That's just videos of you doing an experiment.
Right.
Selfies, Journal of Selfies.
Yeah. Well, her work is really, remarkable. Yeah, this is a great one. And does she couple that with she doesn't even couple it with a model.
We can't see your screen anymore.
Oh, sorry. Oh. John, I mean, I feel like certainly Dave Lively or somebody would have something to say about this in terms of peak frequency change.
Yeah.
Yeah, so that was another area that we experimented with briefly, and giving people different tasks shifts their alpha peak differently. I mean, this is all stuff a lot of people already know, but yeah, like you'll ask someone to watch, baseline, you get one thing. We found really high shifts in frequency when people were reading, but there wasn't a big power shift. So yeah, it's really fascinating, like how it kind of hints at the idea that people might have different cognitive strategies for how they're doing this, just because you give them the same stimulus and you get very different brain response. But yeah, it's really interesting to see like what responses you get, and in particular the fact that people are so different makes it kind of hard to generalize. But I think it is also really fascinating at like what are the implications of the differences for these two subjects.
Have you seen the study about gamma with twins? How gamma signatures in visual cortex is represented the same way with same induced gamma activity for twins. So it's really cool paper.
Oh wow, if you have that paper and you can put it in chat, that would be awesome.
Sure.
Thank you. Wow, yeah. Mm-hmm. Right. Mm-hmm. No, that's an excellent point. And just going back to that slide that Morgan showed, right? If you're imagining that one person has like an 8 hertz alpha, one person has like an 11 hertz alpha, and you look at the difference in like chunking that would imply, one of the areas that we were going to look into is we came up with sort of like these eye tracker based metrics for how long someone lingers on a word and then how smoothly they go to the next one or whatever. So yeah, one of the things that I'd really like to correlate is like visual reading style with which particular brain frequency profile do we see for them for the alpha. So yeah, it's a very interesting area of research for us. And then I do think that eventually you could come up with this idea of like learning your own profile of like, here is how I consume content. And so you could choose the defaults that would kind of be most enjoyable for you.
There's certainly a lot of work on reading. Reading enhancement. Usually, though, it's remediation or trying to help people who are having trouble with that. But there is that subset who focus on speed reading, and what can you do to increase your words consumed per second? Mhm. Well, I mean, have you searched though on Google Scholar or PubMed or something in terms of literature relating to this? Okay. Gotcha.
Oh, it's our special Canadian pulp.
Yeah.
Don't, we can't tell you.
Well, yeah. So I know I don't have more material or presentations. If anybody's joined who would like to introduce themselves at this time, now would be a great opportunity. I'm not
I
checking.
shared my video, a video for the lecture that we made. Just one of them, we uploaded it. Just finished uploading, and so yeah, just for anyone who wants to reference it or has any feedback. But yeah, this course is kind of a lot of our student group. The background of a lot of the people we have in our club is people who are more from the biological or cognitive sciences and not too much programming experience. So we try to start at the very, very basics. But yeah.
Yeah, you dropped that in chat. Sorry, I don't have my chat open.
Yeah, I just dropped it in there.
Great, cool. Okay.
Yeah,
Waterloo has a NeuroTech club, like a NeuroTechX chapter.
Yes, he's running one.
Oh, there is one running at Waterloo.
Oh, sorry. No, Jag's at UC Davis.
Oh no, I was just asking in general. Do you know if there is one running at Waterloo?
There are people creating one recently, so I'm not aware what's the status, but yeah, a few people got together to start a student club at Waterloo.
Yeah, Surya is the guy who's been starting it up, or one of, who's been a student with me this summer.
Sorry, what was his name again?
Surya Pandya Raju.
And I think you dropped his maybe his Twitter in the chat. Is that right, John?
I can put his name in.
Okay.
Yeah, I've just been looking at universities recently. I thought it would be cool to join one that has a NeuroTechX chapter.
That would be great.
Yeah, there's also cool people at Waterloo for sure.
Yeah, it's like I applied for Berkeley, U of T, and Waterloo. Didn't get into Berkeley's, and looking between Waterloo and U of T.
But yeah, you can also just poke me on Slack, and I can put you in contact with people at Waterloo. If the name, or if you cannot find the person, feel free to reach out on me on Slack so I can introduce you.
All right,
or John, I guess.
And so I see John started a thread in random on a general BCI board. And you might remember Josh from the Edgeduino demo and that project. So he's looking for any feedback on this. And oh, thank you, John, for the. I mean, thank you, Yannick, for posting the. I still haven't heard from Meetup on using our own URL. So right now, the only way to use Jitsi is to use Jitsi's service directly, and yeah, okay.
You can post the. I mean, you can post the Jitsi link in the description of the meetup and say right at the top of the description.
Yeah, that is true. I've been trying to hide the URL, and yeah. So okay, and Emma from UCSC. Okay, well, we were just hi Emma. Glad you
Hi
could join.
there.
Yeah. Do you want to say a little bit about what you're finding in these video games, or what you're?
Yeah, I kind of jumped on because I heard that you were all talking about skill transfers, and I work in that area, so I thought it would be interesting to see what y'all had to say. But I think I kind of missed it a little bit, so that was unfortunate.
Well, that's true. So we're at the end of the evening, but this would be a great topic to end on, because I'm curious about the robot operator skills transfer.
Yeah, so I work with robot operators who are professional robot operators at the Monterey Bay Aquarium Research Institute in Monterey Bay. So that's they operate these enormous robots that are very cool and incredibly hard to operate, and they say that video games train them to be able to do that. So it's an interesting situation where we think that those skills are going to be able to transfer over. So we're looking at the kind of, center of the Venn diagram of, where those things are connecting, where those skills are overlapping.
Sure. So is this literally? I mean, are you doing any EEG with these subjects? Is this mostly, behavioral measures?
They're mostly behavioral measures, but yeah. So I'm in a computational cognitive science program, so it's not quite so so tech oriented, but yeah, we are. I was really interested in hearing what reading the paper that was posted and just seeing kind of what people were doing with the EEGs, because that's an interesting avenue that I hadn't thought about.
Yeah, no, I mean, I think it's I'll let Kyle say more, but yeah, I think it's a big question of what should you do with the EEG if you had it.
Right, exactly, yeah.
Yeah, and what now when they are setting up these experiments, though, what are they using? I mean, this is done in advance in terms of what are you expecting to see that you are measuring?
Yeah, so we mostly do cognitive behavioral measures. So there's a large body of research on expert video game players who have spent, countless hours training on particular games, and the cognitive effects that has on the brain, and showing kind of particular areas that are increased in ability. Those kind of can transfer onto. It would be interesting, I guess, for me to see like what exact regions or what kind of activity is happening when those people are doing those tasks. But areas like peripheral vision management and useful field of view and decreasing attentional blink and that kind of thing. I'm not sure if y'all are familiar with these terms. I'm sure you are, but
absolutely. I mean, are you doing eye tracking?
We haven't done eye tracking, only because I think a big portion of this is not like about like, well, I guess so with Kyle's paper, it was a lot about attention, where people are putting their attention, what we were more looking at is in general, like as a cohesive unit, do these skills transfer over onto, like if you trained, for instance, on a video game, would it make you better at operating this kind of robot?
Yeah, Emma, that sounds really fascinating. So we've been experimenting for the past few years. I've got a startup that we're kind of like looking into these same topics, and we've been focusing on the pro gamer esports side of things as well. And the differences are really fascinating. So we use a combination of both eye tracking and EEG, and so obviously that's different than the behavioral studies because you have these other metrics. But it is really, really fascinating to see once you start diving into the various micro strategies and then the kind of more generalized strategies, we do find fascinating differences. So for instance, we found that there's a remarkable consistency in, our term for it is called blink shifting, but really, I mean, it's just blink management, right? It's the same thing. And people will almost never blink in the middle of like a really salient moment. They will do it right after. So one of the pilot studies that we did with Ole Miss University was they had these people play a target training game. It's called Aim Hero. It puts these little targets on the screen and, measures your response and whatever. So the differences are really fascinating. Some people have different cognitive strategies for how they engage, how they track a target, how do they actually move the cursor to the target. But inevitably, we see that they do hold their blink until right after they fire, right after they click the button, and then there's nothing really for them to do. And that seems to be like a good recovery time. So we find amazing consistency between subjects that without having to train their brain, or maybe as part of doing this, that their blink strategy absolutely aligns with the stimulus. And then we see all kinds of other differences in terms of the pupillary response that you get. Like some people have a really large shift in their pupil diameter. Other people have a much more subtle one. We see changes in trends of how people do. So like some people, as they do a task, seem to almost get fatigued, where slowly their pupils drift downwards over the task. Other people have a different effect where their pupils seem to kind of grow during the task, which is kind of interesting that they're contradictory. And then when you add the EEG element to it, you kind of get this whole other level of insight, which is almost like what kind of processing do you think that they might be doing, and so on. So yeah, I think that would be a really cool. I would love to hear more about the research and the robot operators and some of the behavioral things that you're doing. And at the very least, we could compare notes, and I could kind of give you an idea of some of the things you might see in there.
Yeah, it'd be so yeah. If you've got work you can share, Alex, Emma, it would be great to see any papers from your lab too. Just in terms of what you're doing currently, and thinking about things you could add to that. I mean, eye tracking is certainly something that's potentially easy to add. The way Alex is, it's not. You don't have to use, a headset, which I've got here somewhere. It doesn't have to be something, that's expensive or in the way. You could have a long distance eye tracking added quite easy. I mean, I would certainly be interested, even if everybody's, considered a skilled operator, to, see if there are differences in their, their gaze and pupil dilation during the task, or, during sessions, and what that kind of, subgrouping allows you to do with the data, which you wouldn't, if you didn't have that measure, you wouldn't be able to group your subjects into, subgroups.
Right. Yeah. I would like to look at see a correlation between. It sounds like maybe the pupillary response over the course, either the fatiguing or not fatiguing, maybe that has something to do with, how trained you are, or what kind of activity you have going on in those areas, or what kind of background you have. So that would be really interesting to see. Is there a consistency between you know, what the more expert robot operators are experiencing versus what like somebody who isn't an expert in those areas is experiencing.
If I may just chime in quickly, it has been related, like pupil diameter changes in time have been related to neuromodulation of nucleus ceruleus.
Yeah, so you can do. I mean, what's cool is you can do some nice modeling work on that basis. You know, on that pupil dilation, for sure. Yeah. So as Alex is pointing out, this was behind Kamen's and Tversky's. You know, all their behavioral economics work was really focused on pupil dilation and cognitive load. That's great, and I'm definitely super interested in the kind of. I assume these are like submersible vehicles, submersive vehicles.
Yeah, they are. They're remote underwater vehicles. So they are attached to a ship, but they go to the seafloor.
Gotcha. Okay. Yeah. So essentially,
it's crazy. And the control center is like 15 monitors and 2 people manning it, and it's going down there and looking at that is like blows my mind.
Yeah.
Like I don't know how they do it, you know. So part of our work is our lab works with the robot operators primarily to make their job easier. We're hoping to figure out a way to, you know, part of this is a UX standpoint. How do we make this easier? Part of my interest is how do we make people better at these kind of tasks so that this can be a broader field for people, because they essentially can only hire people who are exactly like them and have the same background and the same like crazy skills. It would be really great, I think, to see more diversity in that high skill robot operator arena because of what we would expect to be a booming field coming out of that. So
sure. Well, that's awesome. You know, I remember now. I mean, do you know if the NeuroTechX Club at Santa Cruz?
Sorry, the audio was really glitchy there for a second. I didn't quite catch what you said.
Do you know if there's a student club at Santa Cruz?
Still really glitchy, Morgan.
Yeah, I think he was just asking if there's a NeuroTech student club at UC Santa Cruz.
Impressive.
Yeah.
Wow.
I'm not sure. I could definitely go dig around. We are virtual for the foreseeable future, so see how that goes. But
True. And if you are joining, if you're like, there was somebody asking if there was.
I think we're at that time
Alex
of the
can
program.
understand you.
Yeah, unfortunately.
Alex, can you translate?
I'll have to translate. It's the part on Sprockets where the video gets choppy.
Sorry. It is
still the Bitcoin mining.
It's not C mining. They're working with they are collecting scientific samples for testing in the research lab for the aquarium.
No, that's right. Awesome. Yeah,
right. It's a very difficult skill to kind of be aware of yourself in 3D space when you're looking at a 2D display. And it's even harder when you have to do multiple. So it is very much like a learnable skill to be able to kind of like synthesize these multiple fields and then to create this like virtual projection of where you must be in real space based on the input that you're getting. So I can see why there would be a very specialized skill set that could do that. It's just it's really fascinating to see, you know, that you're trying to understand and characterize that performance. So that's really cool to see.
But
Yeah.
it seems like a skill. It seems like a skill that you could create a VR program that teaches people how to do that, and then you just grow the number of operators.
Yeah, right now essentially it's impossible to. I mean, they hire people before they ever get to train on the actual machine, and
Right.
they've been hiring openly for like 8 years, and they've only hired like 2 people.
Right.
So it's an incredibly challenging field.
Can you drop a couple links for us to learn more about what you?
Yeah, totally.
Yeah, because I mean that is really fascinating.
So thanks for sharing, Emma. Maybe based off what you're saying, it seems like there's some value in predicting who would be a good person to interview.
Yeah, totally. That would be really helpful. I think it would be helpful to kind of have an idea of what kind of training would be helpful for people, depending on, potentially even individualized understandings of their brain. Cultural fit is important too. And so, who has the know-how and the cultural fit, and then, can we train them to have these specific abilities, because that's like such a niche area.
Sorry to are you on the Slack, Emma? Or?
I'm not.
Okay. So I'll put my contact info in the chat, and then we can just chat afterwards, because I just find it really fascinating. I would love to hear some more. So
Yeah, of course.
Well, you could, if you had a VR program that basically replicated the job in VR, and then you're able to assess their biometrics to determine their performance while they're doing the simulation of the job, then you'd know. The TSA has something like that, where they have a number of tasks and they assess your performance while you're doing the task to determine if you qualify.
right. Right. Right.
Sure. And there's a lot of literature on this, and really, always check the disciplines where the fields that have got, in a sense, more people to fill. And, so you can just see in the pilot literature, the kinds of testing and, selection optimizations that are done. I mean, I realize that they're somewhat different, but certainly they push a lot of similar attributes. And yeah, there's a great deal of good physiological, testing. It does make me think, or certainly what Micah said was making me think of Open Mind Technologies. So they're doing these VR EEG sessions, and are definitely trying to then be able to say something about the person from those sessions. And that's the software is TimeFlux, or timeflux.io. Was developed for OpenMind, and again was supposed to be a Hacknight or a hackathon in Paris, but got COVID shut down. Anyway, it is 9 o'clock. I want to recognize the time.
Have a good night.
Yeah, take care. It doesn't have to. I was going to give people a chance to, if there's anybody who's joined. I'm not watching the participants. Anybody who's joined, anybody who wants to follow up, Slack is the best way to follow up between meetings. So anybody who hasn't, highly recommend that. I want to, as always, thank Ryan and Alex for running our live streams and recordings. And always great respect for those on the East Coast that stick with us to the bitter end. I hope moving it an hour early is helpful. Okay. I thought, old friend of mine had a midnight rule. If you're turning into a pumpkin, it's time to stop. Yeah. Any last words? Anything else that I can get into the notes for next week? Oh yeah, and join us Monday, 6 o'clock Paris time if you can. And Kyle,
just roughly what time is that on our continent?
Okay, well, so are you an hour ahead of me?
Yeah.
Okay, so then that's 10 o'clock at your location.
In the morning.
10 o'clock in the morning.
Okay, that's hard. Okay, thanks.
And yeah, so let's see, this week, we'll be continuing to cover the Eureka Challenge, and I see that Yannick has made a new repo for us on the NeuroTechX GitHub. So I think along with John, I'll certainly try and help with a EEG notebooks document that's that we can use to help guide new developers. And it would be great to set a time when you're available for us to talk with Jaden, who, again, he sent me apologies that he couldn't join tonight, but he would love to see BrainFlow, be incorporated and all that new hardware support. So
we should try and set a date for doing that. I don't have access to an open BCI at the moment, so
that's exactly what I told him too. And so I mean, I should have one, and but I don't think that's I mean, I'm certainly happy to help with the document in terms of I think the refactor would be really helpful too.
Yeah.
So,
great. We'll definitely coordinate on that, and
he's super keen. And Mayank, I would love to. I mean, if you posted already any of your projects in the chat?
No, I didn't. I can post my website. It has all my.
Okay. Yeah. Did you put that in the chat?
Yeah.
Great.
I'll do
Great.
that right now.
Okay. Okay. So I've I've literally got it in my notes to collect the chat history before it closes down. So yeah. Any last thoughts?
Just wanted to thank all of you guys. This was my first time attending one of these meetings, and it's been super cool to meet everyone and yeah, hear about all these cool projects going on.
Awesome.
Yeah, same for me. It was good to finally see some people I see in the Slack a lot.
Okay. And yeah, Jag, yeah, really super interested to follow up on your YouTube, and I think I'm a part of the Davis Facebook group. Or anyway, I've seen the posts. I think to Medium, or I've seen some of the activity, and it's been great to see.
Awesome.
And I'll definitely be following up with Kashal on. It was asking me some EEG lab, ERP lab stuff that is, very super relevant, especially for people going through the Center for Mind and Brain.
Absolutely, absolutely.
Okay. Any? I don't think Andre managed to join us this evening. Schmackoff, no. Okay. Yeah. Okay. Thank you so much, everybody. And we will be here next week. If you are interested in somewhat local announcement, for those interested in helping with some of the San Francisco chapter activities, please get in touch with me. And I could maybe use some help getting the Hacknight announcements out earlier in the week. It was not lost on me. I just wanted to say that. Anyway, enjoy the rest of the conferences and webinars that are going on now, and find us all on Slack. All right.
Awesome. Thanks, Morgan. Thanks, everyone.
Thanks, Morgan.
Yep. See you guys.
Thank you.
Good night.
See you guys.
Good night.
All right.
The early hour is definitely helpful.
Okay. Good. Good. I thank you. Thank you for that too.
All right. Bye.
Chat history. All right.
Cool.
Okay.